In this video, we're going to look at circular motion and simple harmonic motion in physics. Alright, so let's begin with circular motion. Now, circular motion in physics basically is expressing the concept of centripetal force and centripetal acceleration. Alright, so let's begin with centripetal force. Now, centripetal force in physics is simply a force that keeps the body in a center of motion and is calculated using mv squared over r. Whereas centripetal acceleration is the acceleration that keeps the velocity of a body in the center of motion and is calculated using v squared over r. Right, so we're going to solve problems on this, so you see how you can apply these formulas to a problem regarding it in physics. Alright, so let's go to simple harmonic motion, SHM short form. Now, simple harmonic motion in physics simply or basically is the periodic motion of a body so that its acceleration is directed toward the fixed point and is directly proportional to the displacement of distance from the same fixed point. Right, and basically there are terms used in simple harmonic motion in physics. Examples of simple harmonic motion in physics: we have the child swing, we have the rotation of the earth, we have your heartbeat. Here is an example of a simple harmonic motion. We also have car shock absorber and the rest of them. We also have the pendulum, oscillating pendulum. So anything that can make a to and fro movement can be considered as an example of a simple harmonic motion. Alright, so let's look at the terms used in simple harmonic motion. We have frequency, alright, frequency, we have period, we have amplitude, we also have angular velocity. Alright, so we're going to look at these basic four terms in simple harmonic motion. Let's begin with frequency. Frequency in simple harmonic motion simply refers to the number of oscillation per time of a body undergoing simple harmonic motion. Frequency is calculated using W over 2 pi, where W is the angular velocity. Alright, it can also be, frequency can also be seen as the inverse of period T. Alright, period, which is a time. Alright, and frequency is measured in hertz. Alright, so that's the unit of frequency in that unit in physics. Alright, now let's look at period, which is T, the time. Now, period is the number of time taken for a body undergoing simple harmonic motion to complete one oscillation and is calculated using 2 pi over W, or you can say to be the inverse of frequency. That's period equals inverse of frequency. Note again that period can also be calculated using 2 pi square root of length over g, where length and acceleration due to gravity is given in a question. Alright, so this is pi. It can also be calculated using 2 pi square root of m over k, where m is the mass and k is the spring constant, where mass and spring constant are given in the question. Right, so let's wipe some parts of here and look at and explain amplitude and angular velocity. Okay, before then, just note that since its period is measured in second, that's the units. Let's wipe this. Okay, so amplitude is the maximum displacement or distance of a body undergoing simple harmonic motion, and amplitude is talking about distance that is measured what in meter, whereas the angular velocity is simply the angle inclined around a circle per unit time. That means angular velocity W equals theta over time. Alright, or angular velocity can also be calculated using 2 pi f from the one of the formulas for frequency. Frequency equals W over 2 pi. So when you cross multiply, W will result to 2 pi f. So that's how I got this 2 pi f. Alright, so don't be confused with it. Now, note again that the relationship between angular velocity and linear velocity is expressed in this form: V equals to WR, alright, or V equals to WA at maximum. Alright, so when the distance is at maximum, right, this A is amplitude. Alright, so at maximum. Now, if you want to calculate the acceleration of a simple harmonic motion is calculated using a acceleration equals minus w square r, where r is radius, or a equals minus w square a, this capital letter A, which is the amplitude at maximum. Alright, so these are basic formulas you need to get used to in simple harmonic motion, and you'll be good to go. Most of them don't need to memorize them, you can just derive them. Alright, so let's wipe this and solve some problems on it before we call it a class. Okay, so let's look at this question. It says the body of mass 20 grams moves in a circular path radius of 10 meters with a constant speed of 4 meters per second. What is the centripetal force? Alright, so before you solve this problem, note that this is very important, that in simple harmonic motion, the oscillation of a simple harmonic motion is said to be damped, D-A-M-P-E, the same to be damped when the amplitude gradually decreases with time. So take note of this. Alright, so let's go ahead and solve this problem. So this is centripetal force. The formula will be mv squared over r. Alright, so our mass is 20 grams, our velocity is 4, our radius is 10 meters. Alright, so very important, you convert this gram to kilogram. So to do that, you divide the 20 by 1000. So now that to convert from gram to kilogram, so we'll be left with 2 divided by 100. We're going to have 0.02 kg. So when you substitute, you're going to have 0.02 times 4 square over 10. When you simplify this, we're going to have 0.02 times 4 square is 16 over 10. Alright, so let me punch this with my calculator and get the value. Okay, so the centripetal force will be 0.032 Newton. Alright, so that will be the answer to this question. Now let's solve another problem. Let's wipe this. Okay, so this question says, what is the period of oscillation of mass 40 kg on a spring with constant K 10 Newton per meter? Alright, so we have our parameters mass to be 40 kg. We have our spring constant to be 10 Newton per meter. I am looking for T. Period is unknown. That means we are going to apply 2 pi square root of m over k. Alright, since we have mass and spring constant, so we're going to have 2 pi square root of mass is 40 is in kg, so no need converting, over the spring constant is 10. So when you simplify this, we're going to have 2 pi square root of 4. Square root of 4 give us 2. So we're going to have 2 pi times 2. So the answer to this question, if you are leaving it in pi, will be 4 pi seconds. Alright, so that would be the answer to this problem. So let's wipe it and solve one more example under simple harmonic motion. Okay, so let's look at this problem. It says if the frequency of 0.75 meter long simple pendulum is 1.5 Hz, the angular frequency on the corresponding reference circle in radii per second is, alright, is what? Now note that angular frequency or angular velocity is measured in this unit radii per second. Take note of this. Alright, so let's look at the parameters. We have our frequency to be 1.5 Hz. We have our radius length to be 0.75 meter. Then we are looking for angular frequency. So we still apply the formula for angular velocity to this. Alright, or okay, let me just say, let's use the frequency formula. Frequency equals W over 2 pi. Alright, so this W here also representing angular frequency will be, when you cross multiply, the angular frequency will be 2f pi. So when you substitute, angular frequency will be 2 times the frequency here is 1.5 pi. So to give us, when you simplify it, you're going to have 3 pi radii per second. Alright, so this will be the angular frequency. So guys, this is basically how you can solve problems involving circular motion and simple harmonic motion in physics. And I hope I explained everything easily for you guys. And with this one comes the end of the class. So that's something interesting. If you're new to the channel, make sure you hit the subscribe button to subscribe to check more videos. Also like, share, and comment on this video. Tell me how you feel. You don't know what you have learned. If you seem to have any specific questions to ask, feel free to leave a question in the comment section below and I will give a response. That's it for this video. Thanks for watching.